Hello everyone. Now we are moving on to Chapter 8, Deformation Joints. This chapter primarily introduces the basic concepts and types of deformation joints, the principles for setting them, and their construction. It is expected that students will understand the reasons behind the creation of deformation joints and the principles for setting them. Additionally, you should master the construction methods for deformation joints. Before delving into the concept of deformation joints, let's first take a look at three sets of pictures to gain an intuitive understanding of deformation joints. The first set of images shows the exterior of buildings, with dashed lines marking the deformation joints. The second set illustrates the condition of deformation joints inside buildings, while the third set depicts deformation joints during the construction phase. From these three sets of images, we can observe that deformation joints are actually structural joints intentionally set by humans. After gaining an intuitive understanding of deformation joints, let's delve into the reasons for setting them. Deformation joints are installed because buildings are affected by factors such as temperature changes, uneven sediment of the foundation, earthquakes, etc., which can lead to additional stresses and deformations within the structure. If no measures are taken or if the measures taken are inadequate, cracks may appear in the building, and in severe cases, it may even collapse. In order to avoid and reduce these adverse effects, in locations where buildings are sensitive to deformation, the structure is intentionally disconnected during design, and gaps are incorporated to allow each part of the building to deform freely, without mutual restraint. This prevents overall damage to the building. These pre-reserved gaps are known as deformation joints. Deformation joints can be classified into three types based on their purposes: expansion joints, settlement joints, and seismic joints. Below is a detailed introduction to the functions, types, and installation requirements of these three types of deformation joints. The first type is the expansion joint. Expansion joints are used in buildings with large lengths or widths to prevent cracks in components caused by thermal expansion and contraction of materials. Due to temperature changes, the entire portion above the foundation is disconnected along the building's profile, while the structural joint's foundation part, buried in the ground, where temperature changes have minimal impact, does not need to be disconnected. The width of an expansion joint is generally between 20 and 30 millimeters. The spacing of expansion joints is related to the materials used in the structure, the type of structure, the construction method, and the location and environment of the building. Relevant structural design specifications have clear regulations on the setting spacing. For example, the design specifications for masonry structures provide the maximum spacing for expansion joints in masonry houses. From the table, we can analyze that the spacing of expansion joints varies with different masonry materials and types of buildings. In the design specifications for reinforced concrete structures, the spacing of expansion joints is related to the type of structure and environment. For example, in the case of cast in situ frame structures, the maximum indoor spacing is 55 meters, while the maximum outdoor spacing is 35 meters. The second type of deformation joint is the settlement joint. Settlement joints are designed to reduce the damage caused to buildings by uneven sediment of the foundation. These joints are vertical gaps that are completely disconnected from the foundation to the roof, including the foundation itself, placed at certain locations within the building. So, under what circumstances do we need to install settlement joints? The first scenario is when the soil quality of the foundation is uneven. The second scenario is when there is a significant difference in elevation or load between adjacent parts of the building itself. For example, in the Shanghai Hongqiao Jinqiao building, the weight of the tower is much greater than that of the podium. This can lead to uneven settlement on the same foundation. Therefore, it is necessary to install settlement joints between the main tower and the podium. The third scenario involves significant variations in building structural forms, such as the connection between frame structures and shear wall structures. The fourth scenario involves adjacent new and old buildings or expansion projects. The fifth scenario is when the building has a complex shape and weak connection areas. In the above 5 scenarios, we need to install settlement joints. The width of the settlement joint is generally greater than or equal to 60 mm. This value is related to factors such as the bearing capacity of the foundation, the weight of the building, and the difference in elevation between adjacent parts. The weaker the foundation, the greater the possibility of uneven settlement, and the larger the inclination distance after settlement. Therefore, for buildings constructed on weak foundations, the width of the settlement joint should be appropriately increased. The specifications provide specific requirements for the width of settlement joints. From the table, it is clear that, as the height of the building increases on weak foundations, the width of the settlement joint gradually increases. The reasons for setting settlement joints and expansion joints are different, but they can be combined into one. Settlement joints have the function of expansion joints, but expansion joints cannot replace settlement joints, because the foundation of settlement joints must be disconnected. The third type of deformation joint is the seismic joint. Seismic joints are vertical joints set to prevent damage caused by mutual collision between various parts of a building during earthquakes. The locations for setting seismic joints are those where stress concentration and structural damage are prone to occur during earthquakes. The general principles for setting seismic joints are as follows. Seismic joints may not be required when the fortification intensity is less than 6 degrees, when the fortification intensity is between 7 and 9 degrees. The general provisions of the relevant specifications shall be followed when the fortification intensity is 10 degrees. Special provisions shall be followed. In which specific situations do we need to set seismic joints? The first situation is when the elevation difference of the building facade exceeds 6 meters, and seismic joints should be set at the point of change in elevation. The second situation is when there are staggered floors in the building, with significant height differences between them. The third situation is when buildings are adjacent to each other, but there is a significant difference in stiffness and weight. The width of seismic joints is related to the structural form, fortification intensity, and height of the building. In multi-story concrete frame structures, when the building height is 15 meters or less, the width should not be less than 100 millimeters. When the building height exceeds 15 meters, for every additional 5 meters, 4 meters, 3 meters, and 2 meters in height for fortification intensities of 6 degrees, 7 degrees, 8 degrees, and 9 degrees respectively, the width should be increased by 20 millimeters. Generally, seismic joints are not required in the foundation, but when the stiffness of connected parts of buildings related to vibration differs significantly, the foundation also needs to be separated. In seismic fortification zones, settlement joints and expansion joints must meet the requirements for seismic joints. When setting deformation joints, the installation of these joints complicates the construction of the building. If not handled properly, it can lead to issues with the building's functionality, such as leakage problems and increased construction costs. Therefore, great caution should be taken when setting deformation joints. For convenience, many buildings have comprehensively considered and arranged the three types of deformation joints to endow them with the above three functions, which is known as the 3-in-1 joint. The 3-in-1 joint means that the joint width is treated according to the width of seismic joints, and the foundation is handled in the manner of settlement joints. The above content covers the concepts, types, and design principles and requirements of deformation joints. In the subsequent chapters, we will systematically learn about the construction methods of deformation joints. Thank you.